Yo, what's up? It's Greg from Harvey Woods. How to solar, reading electrical diagrams for purchasing. If you're building a solar business or you're in the office or you're just trying to figure stuff out so you can quote things. This thing is electrical diagram. You need to know how to read this so you can order the right stuff. Because if you do not have the right stuff on site, you're paying $1,500, $2,500, whatever dollars per day for your guys to be there, right? And you don't have the right stuff, it holds up the entire job site. And those guys are still gonna say, show me the money, right? So we are going to dive into this thing right here. And I'm gonna walk you guys through like how to at least read this so you can get an idea on like how much wire do we need, what kind of equipment, things like that. Now this is a ground mount for a church that we just built up. And so what we see right here, these are our solar panels, right? And we have 1, 2, 3, 4. 4 branches or 4 strings in our solar panels that are going to our power optimizers. Our power optimizers right back there. So the first thing that we kind of want to look at is we want to zoom in. So let me just zoom in here. See this diagram right here? So here's our conductors. So our conductors are our wires. And then here's our electrical ground conductors. These are the 2 types of wire that you're going to need for a PV system, right? So in our diagram, here we have our power optimizers right here, and boom, they run into number 1. Number 1 corresponds to number 1 right here, which is 10 AWG PV wire and copper. And then for our ground, because our ground is kind of separate from our PV wire, we need number 10 as well. So coming from our power optimizers, when we're making our whips via MC4 connection or what have you, right, we're going to be using number 10 wire. So when we're doing our calculations and putting our quotes together and getting everything ready for purchasing in our distributors, right, we want to make sure that we have the correct measurements for our red and our black and our copper with the correct gauge of the wire. Fantastic. So we'll go in and let's just say it's 100 feet of red black, 100 feet red black for each one of these. So 1, 2, 3, 4, like, you know, let's say for our red whips or whatever, we're going to need like 200 feet of red, 200 feet of black, depending on our whips are. So that's where you want to look into your wiring diagrams, and you want to optimize your strings to make sure that you're not spending too much money on wire. So that's fantastic. So once we get there, we go and we hit what's called a junction box. And a junction box is one of these things. So this is made by Iron Ridge. This is a junction box. I have one right here. I believe the Solar Goat has some videos of him attacking a junction box. They're very sturdy, waterproof, durable. They do everything that you need. But a junction box is a place where we can take all of that number 10 wire, combine that together, run a larger gauge wire, right, to our inverter. Right here. So we're not running as many wires. So our junction box is right there. And what we can see here is from our junction box. So with each junction box, make sure that you have strain relief connectors. So when the wires go into the junction box and you try to pull them, right, we don't damage the connections on the inside of the junction box. And we're making sure that everything's nice and tight and to code, right? Because we got to be to code. If we're not to code, we fail inspection, and then guys don't get paid, but they're still like, show me the money, right? So from that junction box, we can look at number 2 to identify the wires that need to come out of our junction box. So here for number 2, we have number 10 AWG THWN-2 and our copper wire. So we have number 10 and our copper wire coming from our junction box. And from that junction box, we are landing into our, in this case, a SolarEdge 7600, and we have 2 of them, inverter. So our L1, L2, and our neutral, right? So now we have, you know, over on the PV side, we had red, black, and ground running from our PV. And then in our junction box, and red, black, and our ground, we go into our junction box. Our ground is maintaining ground consistency throughout the system, right? From our junction box, we're landing into our L1, L2, and then we also have our neutral. And then from there, right, what are the wires that we need in number 3? So we go up to number 3 up here, and we shift down to number 8 wire gauge, right? And number 8 wire gauge here, and number 8 over here for our copper. So what we can see here is we're changing our wire gauge. So in terms of looking at our schematic and knowing what kind of purchasing that we need to be aware that we only need X amount of number 10 wire for this section right here. But once we leave the inverter, whatever distance this inverter needs to go to our load center, which is this right here, right? Here's our load center, about 55 bucks. Now this has 12 spaces. You can do ones with smaller spaces and things like that. But going to our load center, we need to know the distance, right, that we're gonna travel from our inverters to this load center. And on this load center, we're gonna have a 40 amp breaker for each, right? Which is fantastic. And so number 3, if we go to number 3, we're running number 8 from our inverter over to our load center. Fantastic, great. Now we know how much. Now normally what happens is that the load center is really not that far from the inverter. So we're talking totally less than 25 feet for a red, black, neutral, and our ground. Once we land into our load center, in this case, this is a ground mount. So in our ground mount, we like to hang our inverters onto the ground mount array, so our disconnects are located right there, right? And then it goes into Schedule 40 trenching or Schedule 80. So if you're going under a driveway, Schedule 80. Any loads coming down on top of the system, right, that are not just like people walking around, that's gonna be Schedule 80. If we're just a field, if it's just a field, people are walking over it, there's no heavy equipment, no roads, no asphalt, no pavement, none of that stuff, Schedule 40, right? It's really all you need to know if you're running in the residential sector. If we start getting into commercial, completely different conversation. But this is just for the residential guys for right now to get you started. So from this load center, right, this is where a trench happens at number 4. And if we go up to here on the 4 section, we see that we switch over to number 4 AWG and number 6 in terms of our copper run. So in this case, we have about 125 feet of trenching from the ground array that is connected. So we have our 125 load center. So this is sitting on the array, and then it goes down into the trench and over to where our master service panel, in this case it's the rectory, where that's located. And we run that down using our number 4 AWG and number 6 copper ground. And that is going to go to our 100 amp AC disconnect, which is going to be located outside so our fire department, if a catastrophic event happens, right, knock on wood, we put our AC disconnect outside so the fire crew can run up, boom, AC disconnect, the entire thing shut off. So what we see here is we're gonna have to be really key with how much Schedule 40, in this case we don't have like tractors and roads and things like that that are gonna go above this, so we're using Schedule 40. And then in our plans, they're even nice enough to tell us the diameter of the PVC 40 that we're gonna need right here. So this is 1 inch PVC 40, Schedule 40, that we're gonna need. And then number 6 grounding conductor and number 4 wires, red, black, neutral, that are going to be running from our load center into the trench. This is number 4 to our AC disconnect, our 100 amp AC disconnect. And that 100 amp AC disconnect looks like this bad boy right here. Probably one of the more expensive materials. So when you're purchasing a good, like kind of like on an average residential, let's talk anywhere between 10 to 20 kW. So let's say like 5, 10, 20 kW in terms of our system size. Average residential, right? If you budget around $750 to $1,250 per job in terms of AC materials, you should be good. Depending on market conditions and things like that, but you should be good. So like if you're shooting from the hip and you want to close a deal, you want to give somebody a great offer, but make sure that we're not skimping on materials. Never skimp on materials. $750, $1,250, something around there. That's what all of this stuff is going to cost when it's all said and done. This is one of the more expensive items, $274 MSRP. I recommend reaching out to like a supplier like CED Green Tech. Shout out Green Tech. I hope you like this video. We get most of, if not all of our materials from there. And so all of these wires are going to land. So our red, black, neutral, and ground are going to land into our 100 amp AC disconnect. When we're purchasing, we want to make sure that we have the appropriate fuses for the disconnect that we're using. Very key. And then from there, we have another wire run, which is going to go to our main service panel. This is going to, in our case, going to be a line side tap running over into the utility meter, which will become a net meter, and out to the grid. L1, L2 neutral from everything, line side tap on everything. And for this wire run right here, we are going to go and refer to number 5. Oh, let's go back there. Number 5, which maintains our number 4 for all of our conducting wires. That's our L1, L2, and number 6 for our grounding conductors that are going through there. And when we're talking about, you know, the different kinds of things, here it says 1-inch diameter PVC, but this is AC energy running inside at this point, getting to the master service panel. So you have a couple extra options. This is where Enphase is really great, but SolarEdge, in terms of total power production, we wanted this thing to just bump as much power as possible. So we went with the SolarEdge system. And right here, and in terms of our grounding rod and things like that, your master electrician is going to take care of those things. You can look up how much a grounding rod is, but I just wanted to like kind of show you, here are the main things, right? When we're looking at an electrical schematic like this, we want to identify, you know, what are our branches, what kind of wire do we need. For each of these, we're going to need the connections based on the different type of you know, the different type of conduits that we're going to use. In this case, largely we're going to use liquid tight, EMT, schedule 40, schedule 80 if we're trenching, things like that. And so we want the appropriate connectors, strain relief connectors, things like that, things for the master service panel so our wires don't, you know, scrape off their protective covering. But I just wanted to put this out there because I don't see anybody talk about this stuff. If you want me to dive a little bit deeper into where these numbers come from, on how to dive into cut sheets. So, you know, let's say that I'm using a SolarEdge 7600 or I'm using an Enphase IQ8 type system. What should I use? What kind of connectors? What kind of wires do I need? If you want more content like this that you can benefit from, I just kind of wanted to show you. Like here's the schedule 40 that you would use. Here's how you kind of estimate things out. You look at what your costs are. You're able to read your diagrams and know exactly what you need. So when your guys show up to a job site, remember, show me the money. Doesn't matter if they're not there or like the materials aren't there. These guys are still on site. They're still getting paid. So you, in terms of running a solar company and your purchasing department, needs to be very, very clear and very accurate on the types of materials that you are going to need. That's why having a great sales guy who goes above and beyond in terms of their work. So here's another ground mount. Let me just get rid of the personally identifiable. But so this like comes from our sales guy, right? Where he's basically tracking everything that we're gonna need. So when this comes over to the office and purchasing, we know exactly the distance that we need. So we're like plus minus 20 feet there, minus 15 feet there. And we're able to have a very, very accurate bill of materials that we're able to put together. But it starts with the salesperson. If the salesperson is no bueno, it will hurt you financially. So investing in making sure that you have full stack solar engineers is totally something that you want. I just wanted to put this video together, show everybody how to look at an electrical diagram for purchasing, how to understand the different components that you're going to need, and a couple insights that we've learned along the way, and we wanted to just help out. If you like the comment, like, subscribe, share, and leave a comment or something like that. Help the channel grow. The more the channel grows, the more content I can make. Hope everybody's having a great day. Stay shining.
Tonight's report, it feels good.